Let's discuss C solution to LeetCode problem number 314, vertical order traversal of a binary tree. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of LeetCode quizzes to the community page. Please check it out. It will help you in your interview process, as well give a different perspective to the LeetCode problems. Now, back to the problem. I will show you the example we are going to take. So this is the example. So in this case, it is as if somebody is looking from the top and see how the binary tree looks, like the vertical order thing. So they see the 4 first, the leftmost column, and then 2, the column after that, and then they see 1, 5, and 6. 5 and 6 basically they are on top of each other. So if you they come in the third column, and then 3, and then 7. That's how you need to display the traversal of the binary tree. So let us take a look at the solution, which is a little bit more complicated in C than in C++, because of in C++ you have the map to store the columns and which nodes go in which columns. So we have this tree node structure, basically the value and then the left and the right, pretty standard. And then you have this queue item, which basically is the item which goes into the map, so to speak. The horizontal depth, HD stand for horizontal depth. So in this case, the 4 has a horizontal depth of -2, 2 has -1, and 1, 5, and 6 are 0, and then 3 at +1, and 7 at +2. So that's queue item. And then this is just a utility function to create a new node, and then this new queue item is again another utility function to create the new queue item, because one is the actual tree node and this is the one, and this one incorporates both tree node and the vertical column. So now this is the main function, print vertical order, which takes the root, and the base case is if the root is null, you return. And this is the HD node count is the equivalent of the no, it's not the actual map. It is keeping the count at each, how many, it is an index counter at each of the column level. And this HD nodes is the actual map which stores the nodes at each column. So min XG and match HD are needed because you start off in the middle and then go left and then go right. So you need to know, while finally once you build this map, you need to know from minimum HD to maximum HD, and then go through the map and then basically display all the nodes within that map at that specific column. So this queue item is needed because we are going to do BFS, breadth first search, on the tree. And so the front and rear are the pointers, where the beginning of the queue is and where the ending of the queue is. And so we add one item to the queue. We added the middle is because the reason is the tree can go to the left as well as to the right. So you need to start in the middle. The root will be at the middle. So while front is less than rear, you dequeue the one item from the queue, and then so in this case, if you go to the example, you were processing node 1 at column 5 as we see, and so now once you dequeue, you are going to, the temp will have the node 1 and the HD column as well. So now you extract the node and the HD, and HD is initially set to 5 here, and it is the root node, and then you adjust the min and max HDs based on what are the current values, and here you are setting it in the map. So HD 5 and then HD 50 will be set to node number 1. And so then you can enqueue, as we can see. So you add the left child 2 and then the right child 3, and that's what this code is doing here. So these two lines accomplish what I showed in the other screen. And so this is where the actual loop ends, but I just showed this is the entire loop basically. You keep doing the BFS, and finally I'll show you the output from this program in a bit. So then you travel from min from max, and then you'll go through. Now we have to go this one in min and from max is basically an array of nodes at each column. So now this one is actually going within that array at each column, and then I comma j, and then you are printing out the value, and that's it. Now let's go to the actual run of the program. So you add 1 at column 5, and then you add child nodes 2 and 3 for the breadth first search, and then you process value 2 at column 4 because you start off with 5 in the middle, and then as you go left you subtract by 1, and then add child 4 at column 3 because you subtract one more. 4 is minus 2 from the root, and then add child 5 at column 5, and then because you come back at the 1, 5, 6 are in the column number 5. So and then you add you process 3 at column 6 because 3 is to the right, so middle is 5, so at column 6, and then you add 6 and 7, and then you process these nodes. So finally if you analyze it, comes down to, and then you print in that for loop the first for loop, and then this is a very good example of the second for loop. The first for loop comes to 3, 4, 5, 6 and 7. In the case of second for loop, in this the middle column, this I and j, the j is traversing from 1, 5 and 6. That's it. Let me know if you have any questions. Please comment below. Otherwise I will see you in the next video. Bye.